So what if psychological suffering, conditions like deep depression, addiction, or obsessive rumination, isn't actually a chaotic breakdown of the mind? What if instead it's a trap of way too much order? I know, it sounds totally counterintuitive, right? We usually associate mental illness with things falling apart, a loss of control, a descent into chaos. But the latest cognitive science is literally flipping that idea on its head.
Welcome to today's Explainer. Today, we are diving into a genuinely mind-bending neuroscientific framework called the entropic grain hypothesis. We're going to strip away all the mysticism and look straight at the hard science behind how psychedelic therapies, specifically psilocybin, actually rewire the human brain. If you've ever wondered how these compounds fundamentally alter human consciousness to treat intractable mental health conditions, well, let's explore exactly how it works.
Here's our roadmap for today. We'll be walking step by step through the entropy paradox, the brain's fixed attractors, the mechanism of disruption, the annealing metaphor, the clinical evidence, and finally, building new architectures.
All right, let's jump right in. Section 1, the entropy paradox, rethinking mental illness through information theory.
Okay, so what's wild about this concept is how it completely upends our standard view of the brain. In information theory, entropy is basically a measure of unpredictability. So a low entropy system, it's highly predictable, it's constrained, it's ordered. Back in 2014, neuroscientist Robin Carhart-Harris put forward this radical idea that mental illnesses like depression and addiction are actually states of pathologically low entropy. The brain gets stuck in these rigid, repetitive loops. It's literally too ordered. On the flip side, when scientists measure the brain under psychedelics like psilocybin, they see this massive spike in neural signal diversity, high entropy. But, and this is key, it isn't just random chaotic noise. It's variable, it's unconstrained, and highly complex. It actually represents the brain meaningfully exploring a much larger space of possible states, finally breaking free from those rigid, constrained loops.
Moving on to Section 2, the brain's fixed attractors, the architecture of the rut.
To really grasp this, we need to borrow a concept from dynamical systems theory called an attractor state. Just imagine pouring water into a bowl. It honestly doesn't matter where you pour the water from around the edges. Gravity guarantees it's going to settle right at the bottom at the lowest point. The bowl's shape acts as the attractor. Well, our neural networks do the exact same thing. They form these default configurations, kind of like mental grooves, that our mind reliably just returns to. Now, a lot of these are totally healthy and adaptive, but what happens when that bowl becomes way too deep and the water gets completely trapped?
That brings us to the default mode network, or the DMN. You can think of the DMN as our brain's primary self-referential system. It's this central attractor that handles our autobiographical memory and our sense of who we are. But in conditions like treatment-resistant depression, this network goes into overdrive. It becomes hyperconnected. It essentially turns into this steep, inescapable basin. The mind just keeps returning, reliably and destructively, to negative self-evaluation and hopelessness, pretty much regardless of whatever positive things might be happening on the outside. It's not a lack of willpower. Actually, it's a topological problem. The brain is physically stuck in a steep rut.
Which brings us to Section 3, the mechanism of disruption, tracing the theoretical evolution.
Let's rewind for a second. Way back in 1944, the famous physicist Erwin Schrödinger made this profound proposition. He said life is essentially an organized resistance to entropy. Basically, life fights disorder. What's absolutely incredible is how 70 years later, Carhart-Harris inverted this idea for the brain, realizing that sometimes we actually need more entropy. That led to the entropic brain hypothesis in 2014. Fast forward a bit to 2019, and Carhart-Harris teamed up with the legendary computational neuroscientist Carl Friston to publish the Rebus model, which finally laid out exactly how this works on a computational level. So, Rebus, it stands for Relaxed Beliefs Under Psychedelics. This model tells us that your brain is fundamentally a prediction machine. It's always trying to balance two things: your top-down priors, which are your brain's rigid, high-level predictions and beliefs about the world, and your bottom-up signals, which are the raw sensory and emotional data actually coming in right now. Normally, your brain hates surprises, so it lets those strong top-down priors boss around the bottom-up signals. In a depressed brain, that top-down prior is this ironclad belief that things are hopeless, and it literally just overwrites any new positive data coming in. So what does the chemistry actually do to this hierarchy? Well, psilocybin acts precisely on 5-HT2A receptors. These are densely packed on the exact neurons in the cortex that carry those top-down predictions. By binding right there, it basically acts as a volume knob. dialing down the intensity on those rigid priors. It flattens the brain's confidence in its own depressing predictive models. And when those top-down constraints are relaxed, the brain suddenly becomes incredibly sensitive to actual bottom-up incoming data. It accesses way more of its state space, and those rigid beliefs finally let go.
All right, Section 4, the annealing metaphor. Metallurgy meets neuroscience.
And this brilliantly illustrates the whole process. To really make this abstract chemistry tangible, researchers use this awesome physical metaphor of annealing metal. Think about it. If you want to make a piece of metal stronger and remove its structural defects, what do? You heat it up. The heat gives the atoms the energy they need to escape their rigid local constraints and move around. And that is exactly what psilocybin does. It heats the brain by increasing neural entropy, giving the mind the energy to escape that steep depressive rut. But look at steps 2 and 3. You have to slowly cool the metal so the atoms can settle into new, healthier, lower energy configurations. If you quench a metal, cool it too fast, it just becomes brittle. The exact same thing is true neurologically. The brain has to be properly cooled and supported through integration so it can settle into a healthier architecture.
Next up, Section 5, the clinical evidence. Data as punctuation.
54%. In a landmark study published in the Lancet Psychiatry, 54% of patients showed a massive clinical response. We're talking more than a 50% reduction in their depression scores. But here's why that number is absolutely staggering. These were patients with treatment-resistant depression. On average, they had failed nearly 5 entirely different treatments before trying psilocybin. These were the deepest, most stuck neural bulls you could possibly imagine. And yet by increasing entropy, this medicine allowed them to finally escape.
And the wild part is, it doesn't just work for depression. This attractor model is pretty much universal across different pathologies. In depression, the target attractor is that hyperconnected default mode network we talked about, leading to symptom reduction. But in addiction, the target attractor is the reward system, a neural landscape that's been carved into a steep basin by repeated substance abuse. Clinical trials for tobacco and alcohol addiction using psilocybin have shown abstinence rates that actually blow approved pharmacological treatments out of the water. This temporary disruption of the rigid attractor gives the whole system a genuine window to change.
Which brings us to our final part, Section 6, Building New Architectures, the importance of integration.
Because, let's be clear, psilocybin isn't magic. It's a powerful catalyst for profound structural neuroplasticity. Sure, it disrupts those maladaptive attractors, but more importantly, it opens the door to install entirely new patterns of thought. In fact, clinical data shows it durably increases the core personality trait of openness. That means the brain's grooves actually become shallower, and the mind stays more flexible long after the drug is out of your system. But that last point on the list, it is absolutely critical. You need therapeutic support, intentional reflection, and behavioral change to lock those new patterns in. That cooling process from our annealing metaphor is exactly where the real work of therapy happens.
I want to leave you with this incredibly powerful thought from the source material. The entropy opens the possibility. The work determines the outcome. Science has beautifully mapped out this mechanism. We now know for sure that increasing the informational complexity of the brain can disrupt the very topological structures that maintain chronic suffering. But what cognitive architecture you build in that expanded space, how you reshape your own bowl, well, that is entirely up to you. Which leaves us with the ultimate question. If your mind were temporarily freed from its deepest ruts, what new architecture would you choose to build? Thanks so much for joining me on this explainer today, and I'll catch you next time.